Alright, starting another concept. This time we call it examining conditions. And to start off, we'll go ahead and get some variables placed, initialize them. Alright, so there we initialized A and B. Max doesn't need to at the moment, and we'll get to that later. So, to exercise our program, we'll go ahead and get some of my strings out. Let's that. Do a not equal 1. Then we use this question mark right here. Not 1. That's a colon. 1. Then we're gonna have to put a. So there's an actual name for this symbol. They call it the ternary, and basically what it's gonna do, it's gonna look something like this. So this test expression, the ternary, if true, return this. If false, return this. That means if true, return this string. If false, return this string. A not equal 1. A is 1, so that is false. So it's going to return that. Let's see if that's true. It did return the alternative just like I thought. And let me go ahead and get some more code out here to do some more testing. So A modulus 2 not equal 0. And then we test it upon these two conditions. So this modulus is interesting. The modulus value A modulus 2 or 1 modulus 2 equals 1 because 2 doesn't go into it. So the value is the numerator 1. And we're testing if it's odd or even. We know it to be odd, and it is true because 1 does not equal 0. So we can go ahead and run that. 1 and odd. Great. And once again, these are just strings. They could be anything, but the strings that we have just make sense in our program. Alright. And let me go ahead and throw in some more things here. Alright. So now we're testing B. This number 1 or number 2 this time. And we know that it is 2 is not 1. That is true. So it falls upon this first condition. Modulus 2, the value is 0, which is even, so you'll take up the second condition. Alright. Because 0 not equal 0 is false, evidently. And why don't I go ahead and test that right now to prove it, and not just say it. So 1 and odd, that is true. Not 1 and is even. All of that is true. And I spelled it out right here. It's going to be 0. And 0 not equals 0? No, that's not true. 0 is 0. Alright, so here's max in action. So, very concise code here. And let me go ahead and paste this. Alright. So, max equals A bigger than B. Test for true or false. A is 1, B is 2. A is not bigger than B. That is not true. So, B is what it's going to be. So, we're going to do our cout. We break that line. Greater is max. It will certainly be B. Which is true because we got 2. So max is now defined as B from the utilization of the ternary operator. And if we were to just throw a simple cout, it will continue to be 2. Out of curiosity, does initializing it matter? No. It will still become 2. And you can initialize it however you want. That way, even if you started at a 0, it doesn't matter because it gets defined down here. It remains 2. Now, if we were to just knock out that code right there and knock that out, it should be 0. 0. Because it doesn't do this operation here, and it doesn't get newly defined into anything different. It doesn't have to be 0. It could be 5. But this is probably overkill, all this explanation, but what you may be curious about, though, is what happens if we do this. We didn't define it as anything. What's going to happen? This is scary. It might pull out some junk values, right? No, it errors out. If you don't initialize it, it won't even try to use it. So yeah, that's basically all.